There. All right. So, welcome to Math 110's webinar, and we are entitling this Inequalities. And my name is Mr. Dudley. And again, I'm so glad you're here with me this evening. Let me talk about some things we're going to go through tonight. And while I'm going through the sort of the highlights here, you might want to have a piece of paper, pencil, maybe a little scientific calculator. I don't know. Just be ready, take down some notes, okay? So what I'm going over tonight is the lessons that you have going on this week. And I know this has been a very frustrating start to Math 110. You know, I've been doing math classes for Liberty University since 2006. I don't ever remember a start like this. This is pretty hectic for sure. We're definitely having some problems with MyLabs Plus. And you have to understand this is like totally out of Liberty University's hands. I mean, you better believe Pearson is probably working around the clock to try to rectify these technical problems. But, you know, I keep getting emails from my own students, and trust me, all your teachers know what's going on. I can promise you that. Now, we have no clue when it's going to be fixed. The announcement that you guys see on Pearson when you try to log on, they have this announcement on there. That's all we see, too. It's not like we have some kind of inside track to the whole situation. We know what you know, okay? And you better believe that, you know, we're going to do the right thing. We're going to try to work with you this first week, make sure we don't give out late penalties, things like that, okay? So just rest assured, you know, we'll come up with something. We'll make it right and get you guys back on track to where you need to be, okay? So let's get started here. I'm going to go over 16.6, which is solving and graphing linear inequalities. 35.1, which is interval notation. 35.2 and 35.3, which is compound inequalities. 36.1 and 36.2, which is absolute value equations. And then finally 36.4, which is solving absolute value inequalities. So we've got a lot going on here. They're all related, though. I think you should you'll feel the connection from one section to the next. And remember, you know, math is one of those topics that builds upon itself. Okay. All right. So let's just start bare bones here, right? Let's just start from the beginning, the genesis here, right? And go over our inequality symbols. And you guys have seen this. If you have a memory about it, you've seen it probably since middle school, maybe even some of you elementary school, and here they pop up again. And they pop up all throughout math, okay? So we have our less than symbol, and then when they throw the little line underneath of it, we have less than or equal to, right? Then we have the greater than symbol. And then when they throw the line under it, we have greater than or equal to. So when you have the little line underneath of the symbol, it's telling you that it could be equal to it as well. Without the line, it's not or equal to. Okay? Just figure out a way to remember one of these, and I think just logically you'll know what the other one is, right? I always focused on the less than because in my head I could bend that shape a little bit to make it look like an L. When you're like in elementary school, you'll have a clever teacher do something with alligators or maybe Pac-Man or something like that. I don't remember that too well, but I know they do it. It's a pretty popular way to get it across to the students. So however you remember it, just pick a way and go with it. And then one other little rule here that you probably remember when you do inequalities, and that's if you divide or multiply by a negative, and now remember this negative has to come from the variable. So when you divide or multiply by a negative that came from the variable, so like negative 2x or negative 1/2 x, whatever it may be, if you divide or multiply by that number in front of the variable, you will have to switch your inequality sign. So if it was less than, then it becomes greater than. If it was greater than, then it becomes less than. You guys get the point, okay?
Hey, can you explain what from the variable means? That's somebody asking a question.
Yeah, so like my illustration right there when I said negative 2x or negative 1/2 x, that's what I mean from the variable. It's the coefficient is what it's called. That if you see a number directly in front of the variable, such as negative 2x, and you get to that step where you have to divide by it, or maybe you choose to multiply, if it was like a fraction, and trust me, I will do examples tonight, that's when you'll switch it, okay? I have to clarify that from the variable because it's not about did you divide or multiply and there was a negative in that problem. That negative has to come from the variable, that coefficient that was attached to the variable, okay? And trust me, you'll see some examples tonight, so no worries there. The other thing I want to go over with, because when you first start off in this 16.6, if you see that title there, it's called Solving and Graphing. Now, we don't talk about graphing on a Cartesian plane for this. We're just talking about graphing on a number line. So I want to go over a couple of little basics before I get into my first example, okay? So this is like a little rule here that I'm going to repeat several times tonight, and I call it a rule. I just think it's a good practice. As long as your variable is on the left, as long as your variable is on the left, you want to follow the direction of the arrow. And you notice I put that in parentheses because what I'm going to do is I'm going to illustrate all of these symbols right here, and you can sort of see it already that they could look like an arrow. All right, so here's my variables on the left, right? And let's start up here at the top. Let's say I had a less than symbol, or maybe even a less than or equal to symbol, okay? What that's going to mean is that when you go to graphing, and again, I'm going to do an example right after this slide. When you go to the graphing part, you're going to want to shade the line to the left. You see how I turned that into an arrow? Just pretend it's an arrow because you're going to get to this part of the graph where you have to shade. And you're going to wonder, well, where do I shade? What side? Well, in this example, you would shade to the left because it's pointing you to go left. Now, you don't necessarily find this in a math book, okay? This is just sort of my way to help you see it a bit better. They're going to talk more mathematical to you. Tonight's webinar, I'm going to try to break it down, make it sound a bit more simplistic, right? So just think of it as an arrow, go left, okay? Now, if it's less than, you would have what, well, let me go back to that. Here's a greater than, here's a greater than or equal to. And you can see that they're sort of pointing you to go right, okay? And when you get to the graph, and you'll also have to put some symbols. If it's a less than symbol, there will either be an open circle or a parenthesis. I'll practice both tonight. I want you to be well versed in both. In MyLabs Plus, they typically use the parenthesis. I'm a big fan of the circles, as you can see. But if it's a closed circle, you know, MyLabs Plus, they're going to use a bracket. But in any case, once I do my, go through my examples here, you guys are going to have a way better understanding of this for sure. Okay? So just take these notes here, and I think it'll start coming together. Now, on my first example that I want to do with you, okay, it is I try to pick more difficult examples. Okay, I don't necessarily for these webinars try to pick the easiest of them because I think you're going to get the easier ones right away. I try to pick ones that I would typically get questions about. Okay, so like this is one I would get questions about because for obvious reasons, right? There's fractions, and fractions oftentimes scare students, right? And I totally get it. Okay, fractions, can definitely be a bit scary. So let's go over this, and I'll try to pause at the beginning of each of these examples to try to give you time to copy it, okay? So we have this 4x over 5, minus 4, which is less than x over 5 minus 7. All right. Now, the great thing about this fraction problem is that the denominators are the same. And when you get one like that, life is a whole lot easier. So just like equations, just like things you learned a long time ago, let's start off by getting our variable to one side of the equation. And I'm typically in the habit of moving the smaller one. So the smaller one is obviously this 1/5 x. And I'm going to write it as such because oftentimes I find that confusing when they put just the x at the top. Students often forget that there's a 1 in front of it, that coefficient. And whenever you move across a sign, whether it be an equal sign or an inequality sign, you're always going to make it opposite. Okay, so this was a positive 1/5 x. I'm going to make it a negative 1/5 x or a minus 1/5 x. And when I do that, because they are common denominators, remember that's the rule, right? If you have common denominators, you basically just want to leave this part alone, and you're just left with 4 minus 1. So that's easy, right? 4 minus 1, 3/5 x. And then I'm just going to copy down everything else that I haven't used yet. And what you want to be careful with when you're doing this copy and down part, this is a huge mistake right here that students do. You can guess, right? Students will sometimes put down a 7. And that's a shame, isn't it? You put down a 7 instead of a negative 7, you have ruined the problem. See, math is very unforgiving. It is the subject that demands perfection from you. And so whenever you do math, whenever you are in this class and practicing and going through the lessons, you need to be clear-minded and you need to stay focused. I wouldn't do it super late at night. Pick a time where you're, I don't know, when you're maybe well caffeinated or whatever and don't have a lot of distractions going on. And I know for some of you that's difficult. Some of you have kids and jobs and everything else going on. But you need to try to find that quiet time and do the math because it is the subject that demands you to be perfect. And I'm not perfect at it. Shoot, I make mistakes on the webinars. I think when I did this back in the spring, you know, someone chimed in on the chat area and said, hey, Mr. Dudley did this. And I went back and I was like, whoops, I did. So anyways, try to find a good, you know, time to actually practice the math. All right, now that I've got all my variables together, I want to get the numbers together. So I'm going to move the 4, or what's technically a negative 4, over to the other side. So I'm going to add a 4 and get it to the other side. So I now have a 3/5 x, which is less than a negative 3. Now we still have that ugly fraction staring at us. So let's come up with a technique that's going to make this a little easier. 3/5 is a fraction, and you can technically make this negative 3 a fraction. Okay, remember that any integer, remember negative 3 is an integer, any integer can actually be expressed as a fraction. You just simply put a 1 underneath of it, right? I think everybody would agree with that. Negative 3 divided by 1 is negative 3. They're the same. And the reason I'm illustrating this is because I want to use a technique that I like to call cross multiplication. And you can do this when you have one thing, one term, a symbol, and then another single term, okay? In other words, I don't have any plus or minus signs left in the problem, do I? When you don't have any plus or minus signs left in the problem, you can actually use this technique of cross multiplication. It helps you just stop thinking about that fraction, how it's going to cause you problems, right? And all I'm going to do here is I'm going to, green here, I'm going to take this left numerator and multiply it to the right denominator. And then I'm going to take this right numerator and I'm going to multiply it to the left denominator. You should go in that order too. You should do this one first and do this second. Okay? So let's do that. 3x, that variable is going to be with the numerator. It's not going to be down with the 5. You see how it was illustrated up here as x over 5? That's where the x is going to be. It's technically in the numerator. All right? So 3x times 1 is 3x. And 5 times negative 3 is negative 15. I don't have any fraction anymore. Yay, it's gone. So I'm going to now divide. Whenever you have everything isolated now, I've got the variable and I've got the number over here. I'm ready to go. No fractions, no nothing happening. I can now divide by the coefficient or the number that's along with the variable. In this case, it's a 3. Now this is why when I was back at this other slide, let me switch back to it real quick, that from the variable spot, okay, so you notice this first example, I have a negative. It's negative 15 divided by 3. But I'm not going to switch my inequality sign because the negative is not with the x. It's not with the 3, okay? If I was dividing by negative 3, then I'd have to switch it. Who cares if the 15 is negative? That doesn't play any bearing on whether or not to switch an inequality sign. What does is if it came from the variable, in this case, the 3 is coming from the variable. It's a positive 3, so I'm not switching the sign. So I now have x is less than negative 5. Okay? And that's the answer to this one. I want to do a quick illustration, and then I'm going to graph it for you. Let's pretend, and this is just out of pure pretend here. Let's say that I had negative 5 is greater than x. Let's say it came down and it looked like that. The variable's not on the left, and so you can't use that little trick and technique that I taught you right here because the variable's not on the left. But it's an easy fix. You just move it over there. You move the negative 5 over there, and you reverse the inequality sign. See? It's all equivalent. It's all the same there. And then once it's in this format, then you're ready to graph. So let's graph it. Okay? Let's graph this x is less than negative 5. All right, so we got our little number line here, okay, and you know, I'll draw me a little tick mark there, and I have a negative 5. And again, I'm a fan of circles, so I'm going to show circles first, but just know in my Labs Plus they're going to show the parentheses or the brackets. After this example, I will try to stick with parentheses or brackets for the most part, but sometimes I wander and go back to circles. Anyway. It's not or equal to, so we're going to open circle this. And remember, just pretend that this is an arrow. And it's telling you to go left. So that means I'm going to shade to the left of this circle. Now, let me show you the parentheses. It's the same thing. You got a little number line here. But and you're still going to shade to the left, but instead of a circle, you have a parenthesis. The reason I never like these circles, I mean the parenthesis or the bracket, is because I'd have students when I'd hand grade these papers, and I really couldn't tell the difference. It was a whole lot easier for me to tell the difference between a open circle and a closed-end circle when students were hand writing it. Unless I had that student, which I always did, that did this, right? You guys see that, right? It's like, oh, did they mean to shade it in or did they mean to keep it open, right? It's like that student who does this when taking a true-false test. It's like, is that true or is that false? And they hope the teacher will just assume the correct answer. And if they don't, they can argue back and say, well, no, see, that's a T or that's an F. But anyway, got a little off track there. But nonetheless, use parentheses in MyLabs Plus. I may illustrate the circles as well. All right, let's jump to another example. And again, the way I showed this, I want to reference this. The way I showed this to you guys, it's not the only way to solve this problem. In fact, if I wanted to, I could have multiplied everything by the common denominator. See how 5 is a common denominator? I could have multiplied this entire problem by 5. And then gone from there. You still would have got the same answer. Let me illustrate that right here. This is another really popular question that I would get, provided you guys would have access to MyLabs Plus right now, right? And by the way, my examples, come from MyLabs Plus. I don't just make these up out of thin air. I just grab them off of MyLabs Plus. You might actually see this exact problem when you finally get access to it, okay? All right, so we have x plus 5 divided by 6 minus 5 over 12. This is all greater than or equal to x plus 3, which is over 4, okay? And let me illustrate this. Hey, I don't like these fractions. I just want to get rid of them and be done with them. There's a technique called multiplying by the common denominator, or least common multiple, they'll sometimes say, or LCM, okay? So if you can think of the number, or if you can think of a number that all three of these go into, and if you can think of like the smallest one possible, it's going to make life a little bit easier. And so I'm going to illustrate that. So I'm going to multiply everything on the left. Let me make that a little bit better. I tried to grab that. No, it's not letting me. And I'm going to multiply everything over here on the right by the common denominator. And if you haven't thought of it yet, it's a 12. So I'm going to multiply the left by 12 and the right by 12. And how you should think of it is that technically a 12 over 1. Okay? Right? 6 goes into 12. 12 goes into 12, obviously. And 4 goes into 12. That'd be the lowest number that all three of them went into. So that's your LCM. So we're going to multiply everything by 12. And that's going to eliminate all of our fractions, which is awesome. So this is how you do it. 6 goes into 12 2 times, right? And then you still have the x plus 5. Another way to think of that is, what is 12 divided by 6? It's 2. So you just have a 2 left over, and you still have your x plus 5. Okay? It's just like this one over here. It's really 12 over 12, which gives you a 1. So I'm going to put my minus, and I'm going to write the 1, not that you need to see it, but just for illustration purposes. That's what I really did mathematically. I went 12 divided by 12, and I got the 1. And so I'm going to take the 1 that's left over, multiply it to the 5, right? Then I still have this, and then again, this 12 divided by 4 is 3. So that 3 left over here is going to multiply the numerator of x plus 3. And that's really how you do it. Look, I have no fractions left. I got some distributive property to do, but I think you guys are probably fine with that. So let's do some distributive property. 2 times x. And remember, distributive property is you're multiplying literally everything, right? Don't forget that. Okay, so 2 times x, 2 times 5 minus 1 times 5 is 5, obviously. 3 times x, and then 3 times 3. Let's put some like terms together before we start moving things around. I like to simplify both sides before I start moving everything around. Okay? So the only thing I can do is put that positive 10 and negative 5 together. So 10 minus 5 is 5. Now, if you remember what I said on the first example, I'm in the habit of moving the smaller variable over to the larger variable. It helps me to avoid negatives. Remember that little rule, if you divide by a negative that came from the variable, you got to switch to inequality? I try to avoid that rule whenever possible. One way to avoid it is to always move the smaller one. So I'm going to move the 2x over. Do you have to? Absolutely not. You can move the 3x over. So that leaves me with 5 is greater than or equal to x plus 9. Okay? And then of course I got to move the 9 over by subtracting it. And that's going to give me a negative 4 is greater than or equal to x. Now just be cautious here because the variable is not on the left. So I do not want to follow the direction of this make-believe arrow, right? In order to do that, I've got to put the variable on the left. So let me illustrate that on the next slide here. All right, so negative 4 is greater than or equal to x. Negative 4 is greater than or equal to x. So here's how I do it. I just put the variable where I want it. I put the number, obviously, on the other side, opposite of the variable. And then whatever this symbol is, I just write the opposite of it. Notice that it is pointing to the variable here, and it is pointing to the variable there. That's another way to think to make sure that you've done it right. Whatever it's pointing to in the original, it better be pointing to it when you switch it around, okay? And let's get this thing graphed. So we got a little number line here, a little tick mark. There's my -4. I'm going to the left again, which is going, and since this is or equal to, it would be a closed-in circle, or as MyLabs Plus has it, we're going to do a bracket. And then we're going to shade to the left. And of course, what this means is if you're sitting there and you haven't even thought about why are we shading, you know, you're just following the rules here, following the steps, and you haven't sat back and thought about, okay, I'm in a math class. Let me ask myself some questions here. Why am I shading that right there? Well, you are shading that because it is representing all of the numbers that are smaller than -4. All of those numbers, if you were to plug them in to this original inequality that we had, it would work. And when I say it would work, it means that it would be whatever this x is, whatever, if you pick the -5, the -6, the -7, whatever, it's going to be less than or equal to a -4. So that's what it's representing. There's an infinite amount of solutions, right? As long as the solutions are less than or equal to -4, they're going to work in that inequality. The -4 is just sort of like a starting spot, okay? All right, so let's move on to the next section. Now, if you do have questions, obviously you can go to the chat area like some of you have done before. Mrs. Perry will try to do her best to keep up. As we sort of tag team this, and I love that she helps out in that regard. It's awesome. Now let's go over 35.1, which is interval notation. 35.1 is can be a little tricky sometimes for students. Sometimes it doesn't quite click. So I'm going to try to just illustrate interval notation as best as I can, so you get it. When I go through, your instructors will typically go through tests, and we try to find like partial credit to give you. We do. It is. We try to find little things, and when I'm going through and looking at the incorrect questions, I see questions with interval notation missed all the time. So I know it's something that students just struggle with, okay? So we've already talked about the less than and greater than symbols, right? And we know that it would represent an open circle, which is my fave, or the set of parentheses, right? That's what you would use when graphing. And then we've talked about when you have a less than or equal to or greater than or equal to symbols, we've talked about how that's a closed circle or a set of brackets. You know, that's how you represent it when you are graphing. When you start getting into interval notation, you're going to use these parentheses and these brackets that we've used in the previous section, but you're also going to use a different symbol to represent how it extends forever. Remember I said there's an infinite amount of solutions when I was talking about that graph before, because you're going to shade forever and ever in one direction or the other typically, right? Well, if you shade to the left, which I think both of our examples did go to the left, it would represent a negative infinity symbol, okay? And some math books don't even have the negative, and I'm not really sure why. But that sort of represents that it goes to the left. MyLabs Plus are going to use it. And then if I had to shade all the way to the right in an infinite direction, right, then it would just be a positive infinity symbol. All right? Now I'm going to do some illustrations here to try to make this seem easy for you. You might not even know what I'm talking about right now, just seeing the slide right here. I get it. But just let me get through some examples, and I think you'll see it a whole lot better. Okay? So let's start with some little examples that I have here for 35.1 interval notation. And all I did, I just put some basic numbers, but I gave us a bunch of different symbols. I did us a favor and kept all of these examples with the variable on the left, right? That's a good thing. Okay. First thing let's do is this is practice knowing what direction they're going to go in anyways, right? Like we know this, the first one here is going to go to the left, isn't it? Because it sort of looks like the arrow's pointing you left, and we know that this one's going to go to the right. And we know that this one's going to go to the left, and we know that this one's going to go to the right. It's all based off what the symbol is. Less than symbols go to the left, greater than symbols go to the right. Okay? And we also already know that if it's just less than, I would open circle it, right? And I would go left. Or I would do that parenthesis and I'd go left, right? If it was greater than, I would do an open circle and go right, or I would do that parenthesis and go right. And then if it's the or equal to, I would have done the shade in and gone left, or I would have done the bracket and gone left. And you guys get the little pattern here. Or I guess this one I would do the shade in and go right, or I would do the bracket and go right. Okay? Now let's get this translated into interval notation. So I went through all of this for a reason. So I reminded you, because remember math, we're building on things that we just learned. So we just learned about these open circles, parentheses, where to shade, etc., right? So for interval notation, let's put it together using the new bit of information that we just learned right here. That if it went left, I'm going to use this, and if it goes right, I'm going to use that. So let's use that information, okay? So here we go, interval notation for the first one. Looks like this. Let me take you through a little mind process that I go through that I think helps students, okay? Wherever the arrow is pointing you to go, that is where your infinity symbol will go. And the notes that you have right on your paper says that if you go left, you're going to have a negative infinity, and if you go right, you're going to have a positive infinity. So with this first one, it is going left. So I know that I'm going to have a negative infinity because I'm shading to the left, and that's what that symbol is going to represent. Okay? Now, that's going to go on the left-hand side, and on the right-hand side, I'm going to put the number. And this is going to just seem so weird, right? This interval notation. And I'll be honest with you, I'm not a huge fan of it. I mean, it's okay, but I'm like, let's just look at the graph. What do we have this interval notation for? I mean, that's the way I think sometimes. Every time you put an infinity symbol, you will always have a parenthesis next to it. What determines what goes next to the 2 is whether or not it's an open or closed circle. Here, we already know it's a parenthesis, and there it is. That's interval notation. Now, you might have been a little confused on the second one. Just bear with us, right? We got 3 more to do here. No one expects you to be perfect the first time you hear something or see something. And I like to try to change the way I say things just a little bit, hoping that one way that I say it will click for somebody, hopefully everybody. So let's start on the second one, okay? This is just in general, so just keep this in mind. This is just the general format for interval notation. This is what it's going to look like. It's going to look like an ordered pair. You're going to have an infinity somewhere, and you'll have a number somewhere else, and it is very important if it is a parenthesis or a bracket. Okay? All of it is super important. All right, here's the next one. It's pointing me to go right. And I have a note that says if I go right, I'm going to use a positive infinity. And I'm going to put that positive infinity on the right-hand side of this ordered pair. And I remember Mr. Dudley telling me directly next to the infinity symbol will always be a parenthesis. I will put my number to the other side. And since it's not or equal to, I'll put a parenthesis around that too. And that's interval notation. Maybe a little bit better for some of you, I don't know. Let's do a third one here. This one is pointing me left. So that means I have a negative infinity. And Mr. Dudley said every time you have an infinity symbol directly next to it, you have to put a parenthesis, comma, with the numerical answer. Next to the numerical answer will depend on if it was or equal to or not. This one is or equal to, so you have to put a bracket. Looks super weird, doesn't it? That's it. All right. Take 10 seconds. Do the last one by yourself as you're listening, as you're watching. Jump ahead of me. Do it. See if you can get it right. Okay? X is greater than or equal to 2. What is it going to look like? Interval notation. Right there on your paper. Knock it out. All right, here I go. I'm jumping in. It's telling me to go to the right. So I'm going to put an infinity symbol on the right-hand side of my ordered pair. Next to the infinity symbol has to be a parenthesis. Now I'm going to put my numerical answer, and if it was or equal to, which this one is, I'm going to put a bracket. If it was just greater than, then I would have put a parenthesis. And there it is. Hopefully you guys feel pretty good with that. That's interval notation. I've shown every possibility for interval notation. Okay?
Can you go back to slide 7 for a second? I had a question on it.
Okay.
I'm really sorry, and I wasn't paying good enough attention.
Miss Perry.
I know. I'm really sorry.
Okay.
The question was, isn't the last answer 2 instead of -4 on the second example? But that's not the second example, is it? That 5
yeah, this is the second example. 5 minus 9. It's got to be -4. Yeah.
Right. Okay. Thank you. That answered the question.
Okay.
Appreciate you going back. I'm sorry.
No worries. No worries. All right, so this is where we left off. Let's keep going. I actually snagged this example straight off of MyLabs Plus. Who knows, you might get it. Okay? Don't necessarily expect you to write everything down on this one. Okay? Not going to have time to have all those answer choices. Maybe you can write down the original problem. And the reason I wanted to show this one, and this is my last example for 35-1, is because I honestly didn't like it. I'm like, why are they giving the students this type of an example? I think you're going to do fine with the other ones, but this is technically the next section that you're going to get to. This is an answer to a compound inequality, right? It's real weird. I should tell you that this is an and compound inequality. You may not get that yet, but I'm going to go over it when I get to compound inequalities. And what I want to explain to you is that this right here, and I'm going to write it a little bit bigger just in case you can't see it very well. So -3 is less than x, which is less than or equal to 3/2. What this means is that you have two problems, hence compound, even though they don't tell you that. -3 is less than x, and you have x is less than or equal to 3/2, right? They share the x. The x is in the center, they're sharing it. And let's write this one a little bit better because I like that variable on the left, okay? So what I'm looking at is really this, and I'm looking at this. That's what the problem is. Doesn't look like it's written that way, but it is. And see, you wouldn't even have a grasp of this that well until the next section. And anyway, in case you get this in MyLabs Plus, this is a good thing we're going over it. Otherwise, you'd have to take a guess. And I don't want you to do that. So what I'd like for us to do now is just pretend to graph it. If I was graphing this one, I would have done a bracket and I would have gone to the right. Correct? I mean, not a bracket. Why did I do that? Don't jump into the chat area and say, hey, shouldn't that be a parenthesis? I would have done a parenthesis, and I would have gone to the left, right? I think my mind was already on the second one. This one, I would have done a bracket, and I would have gone to the left. So let's look up here at these answer choices and see which one has the parenthesis and then a bracket. Well, this first one is no good because there's two sets of parentheses. So there's no way A could be right because there's a parenthesis on the left, parenthesis on the right. B isn't correct either because both of those are brackets. And what we're left with is there a bracket above a -3 or is there a parenthesis above a -3? Obviously, it's the parenthesis. Just double check the other part's right. It is a bracket, so there's no way it could be C. Hence, D would be the correct choice. So in case you run across this example, hopefully this little illustration here will help you through it, okay? And if you didn't quite get this compound idea here, you're about to, right? Because I'm getting ready to do the section. All right. Okay, here we go. So again, if you have questions like some of you have been doing, go to the chat area. All right. Compound inequalities. Compound inequalities, which just means they're going to throw a couple of inequalities together. And I used to tell my students this when I was in the classroom. And I'd say, all right, when we were learning inequalities and I gave you 10 problems to do, you literally had 10 inequalities to do that night. But now that we're in compound inequalities and I give you 10 problems to do, guess how many inequalities you're actually going to do? And they would get it. They would say 20. I say, right, because it's compound. So one of these is like solving 2 from the previous lessons. And I know that wasn't very fun to hear, but it's the truth. So we have 2 kinds of compound inequalities. We have an and we have an or. Okay? And compound inequalities only represent the solutions that are in common with one another. Whereas or compound inequalities only represent, well, I don't want to say only represent, they represent all the solutions. So they don't have to have anything in common. So just remember, ands, there has to be something in common. Ors, there doesn't have to be anything in common. You can graph anything and everything. And I'm going to show some graphical illustrations of this and then go through some examples. Okay? All right. I guess one thing maybe to talk about here is, I don't remember exactly if you do see it or not, but if you ever see this symbol, that's an and symbol. If you see this symbol, that's an or symbol. The and symbol almost looks like an A, right, if you put a little line through it. The other one is a U-shaped symbol, and actually stands for union, okay? If you happen to see those, one means and, one means or. All right, let's do some graphs. So these are and graphs. Now, how do you know it's an and graph? Well, I told you it was an and graph. And not only that, most of the time they will say and. But here's the best way to know that it's an and compound inequality. It's because you don't see the word or. You might want to write that in your notes somewhere. You're going to know it's an and compound inequality if you don't see the word or. They have to put the word or for a compound inequality, but they do not have to put the word and for an and compound inequality. So my logic is like, all right, well, if you don't see the word or, it's got to be an and. Okay, so here's some examples. Hopefully you have started to write them down. I tried to chit-chat a little bit to give you that time. All right. So here's what I like to do. So I'm going to sort of take you through my thought process. First thing I do is I draw the number line. I put the smallest number to the left, the largest number to the right. That makes sense, right? Let's put the smallest to the left. Let's put the biggest to the right. And here's a great habit to get into. If it's written like this first one, let's separate it, okay? Just like I did on that previous section. I really have this, and I have this, right? And we said, okay, well, let's switch it around. So I really have this. So I've got this problem and I've got this problem, okay? That's what that is. It's nice, these other two that I gave us, I just wrote the word and made it a whole lot nicer, you know? But this one, when they sort of throw it together like that, it's best to write it out separate to see what you're dealing with. Now, here's a good habit here. The good habit is let's pretend that we're graphing the x is greater than -2. And let's pretend that's the only one we were graphing. If I was graphing that, I know it would be an open circle and I would go to the right. And if I was graphing the 3, I know for a fact that it would be a closed circle and I would go to the left. Because we practiced this now, I know what direction to shade things. I know if it's open or closed or parenthesis or bracket, right? Now remember the rule here. And compound inequalities only represent solutions in common. So let's go back here. Doing this little illustration above helps us to see what's in common. It's this area right here. This is what's in common, okay? So now that I know for a fact what's in common, I will actually graph the final answer. So to graph the final answer, I'm going to put an open circle above the -2. Well, let me not do the circles, right? Almost forgot there. Where somebody jumps in, gets me. Let me fix that. Let's do a parenthesis above the -2. Let's do a bracket above the 3, and we shade what's in common. And we're going to shade right through there, okay? And I don't have to guess what's in common because my notes above it, proved to me what was in common. It's where they overlap, all right? It's where the two individual problems overlap. That's where it's in common. All right, let's jump to the next one. This one's already set up for us. I want to do my little notes above it. If I was doing, let's see, I'm going to put them in numerical order. I put the 2 and then the 5. If I was doing the 2, I know I would open and I would go to the right. If I was doing the 5, I'd close it up and I'd go to the right as well. Well, let's see what it has in common. Go right here. So I know that when I go down to my graph, I'm going to put a bracket above the 5. And I'm going to shade to the right of the 5. This is the only section that they have in common. I have nothing shaded or marked above the 2. Don't even put a parenthesis or an open circle. You only shade, you only physically graph what's in common. Okay? All right, let's do this last one. Put the numbers in numerical order. This is a little bit of a tricky one, right? -3 has to go first, and then the 4. All right, take 10 seconds, see if you can do it. See if you can graph this. Make the little notes above it. Pretend that you were graphing them separately. Find out what they have in common, and then go down to the graph and physically graph that. So if I was graphing the -3, I would close circle and I would go left. If I was graphing the 4, I would open circle and I'd go right. Now, I don't have any overlap, which means if this is an and compound inequality and there is no overlap, I have nothing to graph. This is what we call no solution. Sometimes you will see this symbol right there, like a little circle with a slash through it. No solution. It has nothing in common, which means that that compound inequality right there doesn't work. There's nothing in common. It's just not valid. It's an empty set. No solution. Okay? Now, let's talk about statistically when you guys are doing your lessons, the vast majority of the time, you are going to see this illustration right here. Most of the time it is shaded right there in the center, but do not assume that it is. Do your notes, okay? Because if you just keep falling for the one in the center and you're getting them right, when you get that curveball, which could pop up on a test, you need to be ready for it. The vast majority of the time, yes, it is shaded in the center, but sometimes it isn't. So be ready for it, okay? All right, let's jump to an or. Okay, here's some ors. Now, how do you know they're or compound inequalities? Well, not only am I telling you in this slide right here, but remember the little rule. Not a rule you're going to read in a math book, but Mr. Dudley is telling you. If you see the word or, it's an or, compound inequality. They have to put the word or, okay? Nice thing is I don't have anything to rewrite here, so I can just sort of jump to it. All right, so let's see what we got here. Put the numbers in numerical order. So I got a 0 and then I got a 7. And then just pretend that you are graphing them separately. Still keep those good habits that we just practiced, okay? If I was graphing the 0, I would close circle and I would go left with it. If I was graphing the 7, I would have open circled and I would have went right with it, okay? Now, remember, or compound inequalities represent all solutions. They don't care what's in common. It's whatever. Just graph it, okay? So I'm going to go down here to the line, and I'm just going to transfer my little notes there because it's an or. I did that circle again. Let me get rid of it. I want to try to keep it, my math lab, correct. So I'm going to do a bracket, and I'm going to go left with it. A parenthesis, and I'm going to go right with it. So there it is. That's what the first one would look like. You graph anything and everything. Now, if that was an or, it would have been an empty set, no solution. There would have been nothing in common. But ors, you just graph it. Ands, it wouldn't have been anything. All right, second one here. Put the numbers in numerical order, -1 and 6. Pretend you were graphing them separately. So if I was doing the -1, I would have opened and I would have went left. If I was doing the 6, I would have closed it and I would have also went left. Okay? So I have to put this down on the actual graph. Let's see what it looks like. Well, I'm going to put a bracket right here, right? Because I'm graphing anything and everything. I'm putting a bracket above the 6 because it's or equal to. And I'm going to start shading. Now the question is, do I keep an open circle above the -1? Well, let's talk about it for a second. Remember, you graph anything and everything. So if this is going left, it's going to cross over and fill that little gap. So I don't have a gap there anymore. I'm actually going to fill it all in to the left of the 6. No open circle anymore. Don't fall for that. Everything is shaded to the left of the 6. All right? And finally, let's knock out this last one here on this slide. Numbers in numerical order. Make our little notes. If I was graphing the -4, I'd open and I'd go to the right. If I was graphing the 8, I'd close it and I'd go to the left. Now look at here. I got one of them going forever to the left and the other one going forever to the right. So that's going to shade everything. I don't need to put parentheses or brackets or anything. The whole thing is shaded. Everything's a solution. Okay? In fact, this is what we would call all reals. All right? That would be a solution we would reference as all reals. Now, the vast majority of the time when you are practicing or compound inequalities, I will admit most of them look like that, the first one. But use your notes, practice good habits, don't assume that's the or. Okay? All right, let's do a couple of MyLabs Plus examples. So here we go. So for this first one here, this is an AND, compound inequality. And again, maybe guys, maybe just write the example. You're not going to have time to write all those answer choices. If you do that, you're going to feel like I'm going too fast because I can't pause enough for you to write all those answer choices. So let's just do the problem here. This is an and compound inequality, and how do I know? It's because I don't see the word or. What I technically have is 2 less than or equal to negative 2x plus 3, and I have negative 2x plus 3 is less than 7. Those are my 2 inequalities, right? It's one problem, but I technically have 2 things to solve. So let's solve them. It's a pretty basic one, right? Let's just get things away from the variable. I'm going to subtract 3. Negative 1 is less than or equal to negative 2x. If I divide by negative 2, right, I have a negative that is coming from the variable. When I go to divide by negative 2, I'm going to get a positive half, and I have to switch my inequality sign. So now it's greater than or equal to x. You guys follow me there? I divided by a negative. So remember that little rule from early on in the lesson. I like the variable on the left, so I'm going to rewrite it. So my first one is this. X is less than or equal to a half. My second one starts off the same way. I just subtract 3. I get negative 2x is less than 4. I'm still dividing by a negative. So instead of less than, I now have greater than negative 2. 4 divided by negative 2 is negative 2. Okay, this is an and compound inequality. And so if I have my number line here, I would have negative 2, and I would have a half, right? If I was pretending to graph them, I would close circle and go to the left with my half, and I would open circle and go to the right with my negative 2. And I would learn that right there in the center is what they have in common. Now let's translate all this and go to my answer choices here. Okay? You guys can see that A, there's no way in the world that's correct because they're saying the answer is negative 3. All right? Plus the bracket's in the wrong spot, so we know it's not A. Let's look at B. We know that it is not B because there's 2 brackets. Plus, they have the wrong answer. They have it going to a negative 1, so we know it's not B. Let's look at C. C is not correct because they're both parentheses. And not only that, well, that's the only reason. So they're both parentheses. C is no good. And then D, D's the one that matches. D is good. D shows a parenthesis above the negative 2 and a bracket above the half, shaded in the middle. D, correct answer. Okay? All right, and then let's do a OR. So this is an OR compound inequality. How do I know it's an OR? Because they have the word OR in it. And look, we got like more answer choices. So let's see what we got here. X minus 5 is less than negative 8, and we have x plus 6 is greater than 11. These are ORs. Okay? These are just one-step solutions here, right? It's one little step. Add a 5 for the first one. And subtract a 6 for the second one. Okay? So we got negative 3 and 5. All right. Let's look at our answer choices here. Just by knowing, going through our examples before, we know for a fact that it's not going to be D. D is a clear and compound inequality. We know it's not going to be C because you're not going to run into some no solutions for ORs. You can run into no solutions for ANDs. I'm going to run into that for ORs. Now let's just figure out by actually doing the graph what we've got to deal with. So we've eliminated a couple of them. I don't feel that confident in, let's say, for sure we can eliminate the other ones just by glancing at them. So let's go through the motions here. This is a -3, this is a 5. This would have been open to the left, this would have been open to the right. So that's what we're looking for. So we're not looking for this all reals. F is all reals. We're not looking for that one. We're not looking for all of it going to the left as in B or all of it going to the right as in E. We're looking for that typical OR graph. One goes to the left, one goes to the right, and there it is, A. All right? Okay, well, let's jump to the next section, shall we? Let's jump to the next section. So now we're going to do absolute value equations. Sort of weird, right? We're in learning about inequalities, and then all of a sudden they want to give us some equations. And then right after this, we're going to jump back to inequalities. So we just sort of sneak in this equation here a little bit. And the reason is we sort of have to have a basis, a little groundwork before we jump into the absolute value inequalities. So let me read what I got here. Always remember to isolate the absolute value first. Okay, you want absolute value to be all by itself. You don't want anything on the same side as your absolute value symbols. Absolute value symbols are those little bars that you see around the X there in my illustration. If you didn't remember what they were, that's what it is, okay? Then, if there is a second equation, always negate the opposite side. So these are just some things to remember as you're solving, okay? As you're writing some of this down, let me just try to refresh your memory on what absolute value is anyway, right? It's the distance from 0 on a number line, okay? And just the very definition, right? The distance from 0. Let's think about that. Have you ever heard of someone traveling a negative distance? Right? No. Don't travel. It'd be nice. I've got a truck that's got like 260-some thousand miles on it. I'd like to travel some negative distance on that and get the value back on it a little bit, especially if it was even possible to make the engine and transmission and everything else better. But it's not going to happen. So let's keep that in mind, right? Absolute value is the distance from 0 on the number line. Distance meaning that it's going to be not negative, right? So when we look at this first example here, if I have this absolute value isolated all by itself and it's equaling a -1, this is impossible. That's not going to happen. So if you ever run across this example, which they do pop up in MyLabs Plus, you pick the one that says no solution. All right, so like a real life little example here in MyLabs Plus would be something like this. You know, they would say, oh, hey, absolute value of 3x minus 1 is equal to -2. No, it's not. Yeah, absolute value cannot equal a negative number. Keep in mind, though, it has to be isolated. All right? Now, what if we have the absolute value of something and it equals 0? That's possible. Right? It's possible to travel 0 distance, okay, not go anywhere. In this particular case, which rarely happens, but if this happens, you're only going to set up one equation, okay? Now, if we have absolute value equaling a positive number, like 1, then you're going to set up 2 equations. And this is where that little rule right there comes into play. If there is a second equation, always negate the opposite side, meaning the side that's not absolute value, okay? So I've given you a negative illustration, a neutral, 0 illustration there, and a positive illustration. Can't do one time, do twice. Let's actually jump to an example, okay? So here we go, first one. -7 times the absolute value of 2x minus 3 plus 37 is equal to -12. Now, I will often get questions about this one. And one thing you don't want to do is to distribute the -7. That's a big no-no. This is not the distributive property. Don't distribute the -7. Okay, you don't want to do that. All right. And then students often struggle with, okay, well, how do I even start this problem? And anytime I get a chance to talk with a student about it, I will write this counterexample. And I'll say, okay, let me ask you this. You're obviously intelligent enough to do that one right away. What would you have done first on this example? And everyone's going to say, oh, I'm going to move the 37 over to the other side. I'm going to subtract it. And I would say, exactly. That's what you're going to do here. You're going to move the 37 over to the other side. You'll do the same thing. Don't think just because you're an absolute value, all of a sudden there's all these different things and elements of just the basics of an equation, okay? So we have -7 times the absolute value of 2x minus 3 is equal to, and now we have a -49, I believe, okay? So let me do that up here. I would say, okay, yeah, move the 37. That's right. Let's move the 37. I don't know, I got that other little dash there, but anyway. So -7. And then I'd say, all right, what would you do next? And they'd say, oh, I divide by -7. I say, well, right. That's what you're going to do here. You're going to divide by -7. So we have absolute value of 2x minus 3 is equal to 7. Okay, now, absolute value is now isolated. I can now make a judgment call from my previous screen. If I have an absolute value equaling a positive number, then I'm going to set up two equations. So what I'm actually solving here is a 2x minus 3 is equal to 7, and I'm solving a 2x minus 3 is equal to a -7. That little note that you wrote on the previous slide, if there's a second equation, always negate the opposite side, meaning the side that's not absolute value. Also pay attention. I did not change anything that was an absolute value. I don't have the absolute value bars anymore. And when I wrote both equations, I didn't change anything. Don't make it all of a sudden a +3. That's very tempting. If you remember anything about absolute value, you probably remember something about, oh, if it's negative inside absolute value, when I take it out, it's positive, right? Because it's the distance from 0. It's going to be positive because you can't travel negative, all that stuff, right? Don't do it here. Leave it alone. Leave it exactly the same, okay? So I'm just going to solve these two basic equations. Very simple. 2x is equal to 10, which means x is equal to 5 when I divide by 2. Here I'm going to add 3 as well. And so 2x is equal to -4, which means that x is equal to -2. And so those are my answers. The 5 and the -2 will satisfy the original absolute value equation. If I plug a 5 in there or a 2 in there, it's going to give me -12. Okay? All right, let's do another one. And I'm going to tell you, this is the #1 question I'll get, is this next example. The #1. I would have already had several students email me about it, but you guys don't have access to my Labs Plus, so I haven't got any emails yet. I was thinking, I wonder why no one's asked about this one. Well, it's because you don't have access, all right? This one just looks like intimidating, right? Don't be intimidated by it. We'll use a technique that we learned way back at the beginning of the lesson, and that's why I did it. Remember this right here? I talked about, oh, cross multiplication. We're going to use that technique here, and we're going to cross multiply this one. The wonderful thing about this example is that absolute value is isolated. So I can go ahead and set up my two equations. I'm going to solve a 5x minus 1 over 6 is equal to 4. And I'm going to solve a 5x minus 1 over 6 is equal to -4. And I'm going to use the cross multiplication technique. Not that it's the only way, it's just I've already shown it. Let's stick with it. It works. One thing equaling one thing. One term equaling one term. Okay? So if you remember, I'm just going to cross it up. And to see that a little bit better, I'll put a 1 underneath of each of these, the 4 and the negative 4. So everything at the top right times everything at the bottom. I'm sorry, everything at the top left, the left numerator times everything at the bottom right, the right denominator. So that's just 5x minus 1. And then everything at the bottom left times everything at the top right, so that's 24. Let me go ahead and cross this side too. 5x minus 1 times 1 is 5x minus 1. 6 times negative 4 is negative 24. So let's solve them. Have 1. What did I put 26 for? Oh no. It's because my mind went somewhere else. 25. Divide by 5. X is equal to 5. All right. This one over here. Add 1. Add 1. 5x is equal to negative 23. If I divide by 5, x is equal to negative 23 fifths. You guys want to leave things in improper fractions. My last class is not going to do mixed numbers like this, problems like this. You usually see mixed numbers like back in middle school. Once you start getting like algebraic type stuff, they just automatically start going to improper fractions. And that answer right there, the negative 23 fifths, doesn't that make you feel like you screwed up? It's like, oh, I got this nice 5, I feel good. And then you get this negative 23 fifths, and it's like, oh, I must have done something wrong. This just looks so weird. Fractions aren't weird, right? But I get it. It does make you feel something isn't right. All right. We're almost done, guys. I appreciate you hanging in there. It's a long, webinars can be a little long. I appreciate you, sticking with it and hanging out. I hope you're learning something, that when you finally get access to My Labs Plus, you're going to feel good. Okay? Last section here. Let's knock it out. I think I probably threw some animation around this. Yes, I did. So 36.4, we're going to solve absolute value inequalities. Always remember to isolate the absolute value first. The same rule as the equations. Then, if there is a second inequality, so if you have to set up a second inequality, just like we set up a second equation, here you have to keep, change, flip. In other words, keep what was an absolute value, flip around your inequality sign, make it opposite, and then negate the number. Make it opposite of whatever the number was. Right? That's what you're going to do. Okay? Then let's talk about absolute value inequalities and just reference that they're just like compound inequalities. So here we're now going back to compounds. Okay? You see how this stuff builds? You can't afford to like miss concepts and expect to just get it when something new is taught. Okay, you got to stick with these concepts. We're just going to build on everything. So we know that we have these less than symbols. If you see that on an absolute value inequality, I want you to not say less than, I want you to say less than. Less than. That's how you're going to remember it. If you see less than symbols, this is provided the variables on the left, like I've been preaching the entire night here. If you see a less than symbol, it is an and compound inequality that you're going to set up. And it's just a little play on words that I did right there. Less than, it's an and. So think about the other one. How do you think I'm going to play on the words here? Right? These are greater than symbols. I'm going to say great or, right? If you see greater than symbols, it is an or compound inequality. All right? Or compound inequality. Again, you're not going to see this stuff in a math book. This is just me trying to make it just seem more simple to you, because it really is. I mean, you guys can do this. I promise you. Okay? There have literally been, of course, I don't know this for a fact, but come on. There's probably been 1 billion+ people that have done these topics before over the course of history, right? You can do it too. We're not talking rocket science here. I know it might feel like rocket science sometimes, but understand it's not. You put in that effort, you put in that study time, you can do it, okay? All right, so if you see a less than symbol, it's an and. If you see a greater than symbol, it's an or. Less than versus great or. All right, let's talk about these examples right here. All right, let's go through some illustrations here. Talk about how many inequalities you would set up, etc., like I did with the equations. Okay? The first one there. If you have an absolute value of something and it is less than a negative number, you have to know that that's impossible, right? The absolute value is going to end up being positive. Is a positive number less than a negative number? Of course not. So if you happen to run across an example where the absolute value is isolated and it's less than a negative, you know that it's impossible. You can just write your answer and be done with it. The opposite would be true here. If you have an absolute value that's greater than a negative number, all right, well, that's always going to be greater. That's an all reals answer, okay? All reals. Now, let's say I had an absolute value that's less than 0. Well, I could technically say that that's not possible, right? And it isn't. You might want to make a little note of that. You're not going to have one that's less than 0. However, let me change it just a little bit. If it was or equal to, then that would be possible, right? Absolute value can be equal to a 0. Same with this one over here on the right. If absolute value is greater than a 0, okay, yeah, most of the time, right? Maybe not all of the time, because what if it was 0? Okay, just things to think about. Well, if this one right here, so in your notes, if I didn't put this or equal to sign, it wouldn't be possible. If I put the or equal to sign, you would set up 2 inequalities. Okay? This one right here, if I don't have an or equal to sign, okay, it would still be, it would be 2 inequalities. Okay? If you were to have put an or equal to sign there, you could technically call it all reals, right? Now, let's go down here. Both of these illustrations, you're going to have 2 inequalities, okay? You'll set up 2 inequalities. And guys, you know what? The majority of the time, like these little scenarios that I went through up here that you may have gotten a little confused about, especially with this second row here, those are rare. Those aren't going to really happen. But MyLabs Plus is going to get you practicing setting up 2 inequalities and going with it, okay? So let's do one together. Let's go right here. First things first, let's write it down and let's get it isolated. Absolute value, 2x minus 6 minus 7 is greater than negative 3. Okay? To get this isolated, I'm going to add the 7 to both sides. So absolute value of 2x minus 6 is greater than a 4. Now, you have to decide whether or not this is an and or an or, because it's going to shape your graphical answer. It's not going to shape how you do the next step. It's going to shape the graph. And the graph, because this is straight from MyLabs Plus, is where the answer is coming from. Now, remember what I talked about back here, great or. So I know this is an or compound inequality. Okay, I can make that statement right now. This is an or. All right. Knowing that this is an or, I could automatically eliminate C and B because those are definite ands. Those cannot be ors. All right. Now, let's talk about how to set these up. So we're starting to run out of a little bit of space here. So I'm going to set up 2x minus 6 is greater than 4. And I'm going to set up 2x minus 6 is less than or less than a negative 4. I keep what's an absolute value, I change my sign, and I negate the last one. Keep, change, flip. Sometimes people say that too. Whatever helps you remember it. Keep the absolute value, change the symbol, negate the number. And these are the two I'm going to solve. So 2x is greater than 10, which means that x is greater than 5. 2x is less than 2, which means x is less than 1. Okay? I added 6 in both scenarios, and I divided by 2 in both scenarios. I think you're with it by this point, right? Now, let's do a little graph. I would have my 1 here. I'd have my 5 here. If I was graphing the 1, I'd go in this direction. If I was graphing the 5, I'd go in that direction. All right? Since both of these are not or equal to, we know it can't be A because those are brackets. It has to be D because that's the one that showed parentheses. And I know it would have been possible to knock this problem out without even doing that work. Sometimes that happens on multiple choice. This is a pretty poorly created multiple choice item. It happens sometimes, okay? We didn't really have to do any of that work if you'd have just used your head a little bit, okay? I don't recommend that. I recommend you getting the work in, practicing it, but nonetheless, all right? That was the last example. I know you guys are super disappointed, but I want to say a few things before I let you go. There's always additional resources. Within My Labs Plus, there's Watch It videos. There's Help Me Solve This. And not all of them have these things, but the vast majority of them do. The one thing that they all have is the Ask My Instructor. Okay? They will have that, and that'll give you a direct connection with your instructor. But don't just send them a blank email when you click on that, and don't just say help. Please be specific about what you need help with. Show them a little bit of work. Show them you know a little something about it, okay? Don't just say help. That doesn't really give us a lot of insight. Like, what do you need help with specifically? Because I could write you a book about it, okay? Be specific. There's also free one-on-one tutoring when you're with Liberty University Online. That's through tutor.com. Check in with that. Maybe get in touch with your academic advisor if you don't know how to do that. You got Khan Academy, which is an awesome site. You guys have probably heard about it. It's been in the news. I like Purple Math. Purple Math is pretty cool. Or you can just simply Google inequalities and absolute values. I mean, whatever. Just Google the key phrase. That always helps as well. I do have some upcoming webinars, okay? Mark your calendars. Set aside some time. September 7th, that's next week. It's a Wednesday. I'm going to teach you how to graph a linear equation. Then I'll see you on the 27th, which is a Tuesday. We're going to factor polynomials. Definitely be there for the 27th. Man. Put it in your phone, put it in your calendar, something. You're going to want to be there for the factoring. And then I won't see you again until November. Wow, so we skipped the whole month of October. And I'll see you for completing the square and quadratic formula. Okay? Thank you so much for being here tonight. I tried to be as thorough as I can. I apologize I may have took too long. Leave me a little feedback if you don't mind. And you guys have a wonderful night. Let's cross our fingers that my